Hello and welcome to the STEMCstudio channel and another episode in our Geometric Algebra in STEMCstudio series. In this episode, we're going to move our vector forward a little bit more on its journey to becoming a full-blown geometric number. We will specifically be adding scalar multiplication, and that's going to be a little bit different from our use of operator overloading in the previous video. We'll also add a few, you might call them cosmetic adjustments to our vector to make the vector a little bit more usable for people using it, and also to improve the rendering of the string representation using MathJax. Okay, let's get started. So you'll recall in the last video that what we did is we implemented a vector just as a simple pair of numbers. We added a method for adding two vectors together, and we provided the corresponding method that did operator overloading. And then finally, we added a toString method that would provide a string representation of the number. What we'd like to do first is we would like to improve the documentation a little bit. So if you start hovering over different parts of the class, like hovering over the vector here, you'll see it's not producing any documentation. The constructor is, and that's because of the JavaScript or the Javadoc style comment that we have here, but it's actually not complete. And then further, if we go to where we're using it, if you hover over various things like the vector itself, the basis vectors E1 and E2, we don't get any extra information. The constructor's not too bad, okay? And yep, even the properties are not giving us a lot of information. So let's go and fix that. We'll right click on vector, go to definition. And one of the things that we can do here is just add a JS style document at the top of the class, and we can say a vector in 2 dimensions. I won't say much more than that at this point because we actually haven't really defined much more for this. If we hover over vector, we see it says a vector in 2 dimensions. That's great. If we come back to index.ts and hover over that, you can see we've got a little improvement there. Okay, let's take a look at these E1 and E2. We'll give that a little JS document. Okay, so what is E1? E1 is a basis vector. A basis vector. And it's kind of really hard to say what else we should say about this here. In the, let's say, X direction. Similarly, we'll say here. In fact, I'm going to change this. I'm going to make it the basis vector in, even better, even the basis vector corresponding to the y coordinate or y coefficient. I think people say coordinate, coefficient, component. None of them is really very satisfactory. But actually, I think that in some ways coefficient actually says what we want much better. So the basis vector corresponding to the x coefficient. Okay, so we can hover over these now, and that's a lot better. Hover over these. Those are a lot better. Okay, what about the constructor? So the constructor takes parameters x and y, but we haven't really described what those are. So the syntax for that is @param, the name of the parameter, and then we can say here I'll use lowercase, the coefficient corresponding to the E1 basis vector. Okay, the coefficient corresponding to the E1 basis vector. If we hover over this, @param, the coefficient corresponding to the E1 basis vector. Let's do the same for y. coefficient corresponding to the E2 basis vector. Okay, so constructor, a little bit more self-explanatory here. We will actually in the future, we're going to try and discourage people from using this constructor, and instead have them use convenience methods, but that's down the road. Okay, so what else should we document here? Well, we probably should document the add method, because you can actually use the add method directly. This method here, we don't really use directly. It happens through operator overloading, so that really shouldn't be seen. So here what we can say is, let's say we can say, well, there's obviously a parameter and right-hand side. And that's the vector to add to this vector. And we could perhaps use the returns keyword, returns this plus right-hand side. Okay, and there's no need to say that this is a vector, because it's actually built into the type definition. Okay, so it just returns this, right? And you might say a new instance. What I'm trying to suggest here is that it doesn't modify this vector. What else can we do? ToString, yeah, we can use ToString. I'm not going to worry about that right now, but you get the idea. Okay, the next thing we want to do, let's run this, is we want to improve the printout here so it looks a little bit more natural. Okay, so what we're going to do is we're going to use MathJax for that. So MathJax is a library that can take mathematical expressions in various formats, and it can render those in a sort of more natural mathematical syntax. So to do that, we first need to make MathJax available to our project. So we head over to project settings. You can see here that the title is not really very appropriate. Journey to Geometric Algebra. I guess that'll suffice for future. It's not really important. This is just maybe something that'll become more useful in the future. Let's find MathJax here. There's MathJax, and we'll take the latest version, which is 3.14. Okay. All right, so to actually use MathJax, there's two things that we'll have to do. One is that we want to use it for our own print line statement down here, and the second is that we want to use it in JSXGraph. Now, to use it in JSXGraph, we basically have to prepare JSXGraph a little bit. So the way to do that is you type jxg.options dot, and then it's text, and then dot, then use MathJax, and we say true. Okay, so that's going to set us up correctly now. You'll notice this, we've got this sort of type behavior saying, hey, text is kind of optional, it may not be defined. I'm not sure here whether this is sort of really to be considered an error in the way that the system is typed. I'm not quite sure what the correct semantics of this API should be. And so this may not be the sort of the correct ultimate fix. But what we can do here is we can just make this conditional. And TypeScript knows that if this evaluates to true, if it's truthy, then text is safe to use. It's just text options now, and we set use MathJax true. Okay, the final thing that we then need to do is we need to sort of surround our usages of our names with a sort of an escape sequence which indicates that it is MathJax. So the way to do that is a double backslash, square braces, double backslash, and then close square braces. Okay, and we may need to stop and start, but actually no, it looks like it's recomputed here. So we've got E1 coming out now the way we want it. You can also use $, I think. And yeah, there it is. We got E2. Now, actually, we can do obviously a lot better than this. We want to make it look like a little underscore with a subscript. So to do that, I want to use the underscore and then 1, and you can see it's dropped it down there. That's exactly what we want. Okay, so here it would be E underscore 2, like that. And just see E1, E2 looks kind of quite pretty. And then let's do the same for A here. So I think for consistency, we should sort of stick with one or the other. I'm going to go with actually the square bracket form like that. And I'll make this the square bracket form too. Oops, do that again. Double backslash square brackets. Okay. And so are we good there? E1, E2 looks good. A, I'm not going to bother with these other ones, B and C, because we actually won't be using those going forward in our work today. Get rid of them all. Okay, so what can we do then to improve this down here? Well, what we need to do is we need to also escape. So we'll do this and close off. Okay, now you can see nothing's really happening at this point. That's because what we need to do is we need to give MathJax a little hint that it needs to typeset. Okay, and the reason for that is that, recall this DOM ready, MathJax did its initial processing when it thought the DOM was loaded, but now we need to make sure that it's kind of processing at the right time. So you can use typeset. Typeset promise is a variant, and you can look at the JSX graph documentation to understand exactly what we need there. Okay, so didn't kind of quite work out. I've got forward slashes, need to have backslashes. And okay, we are getting there. E underscore 1. So that's looking better. But now what we have to do is we need to go to our vector and modify it so that it's returning a sort of a MathJax-y form. Now, obviously, you could have different kinds of variations here. You could have some, vanilla toString or whatever, but or toLatex or something like that. But we'll do this. Looking pretty good. Now, one of the things with MathJax is that, we don't really need to have this multiplication symbol anymore. So now we got 1E1 plus 0E2. And you can obviously see that, we could really improve this toString because, the 0E2, we don't need to know about it. And 1 is just 1. It doesn't change anything. And so, E1 is just E1. No great surprises. But we'll get to that. Okay, so let's go back and just pretty up the rest of it. So backslash square there, double backslash, close the brackets, and there's the E2, and then finally just the A. Okay, and so A is 1E1 plus 2E2, which is just really what it was defined to be above. Recall that this constructor constructs the vector, which is x times E1 plus y times E2. So we expect it to be 1 times E1 plus 2 times E2, which indeed it is. Okay, so two things that we just did there. One is that we used MathJax, and one is that we just improved our documentation of the class so that we got better documentation when we're hovering over it. Okay, I now actually just recall there's one thing in the last video that I was sort of reaching for. I couldn't remember the term. When we have a string like this, okay, that's, and then we embed the syntax with the dollar curly braces, and then variables we want to substitute. This is called string interpolation, okay, which just basically means it's going to substitute values into the string, and you don't have to kind of like explicitly go and build complicated kind of concatenation statements. Okay, so it's just a very nice, elegant way to work. All right, let's get back to the business of scalar multiplication. What we would like to do is we would like to do something like this. We'd like to create, say, a new vector like const, and I'll use the word 2a equals, say, 2 times a. Or we might want to do something like a times 2, something like that, okay? 2a is obviously not being used right now. Let's have it be used. So we can say 2a is equal to, and it's equal to 2a. And clearly we're not going to get anything right now because we haven't overloaded the multiplication operator when it happens with a vector on one side, that's a. Okay, trying to hover over there for you. Can't get my mouse in the right place. There we go. A is a vector on one side, and this on the right hand side we probably won't get anything, but it's just a number. Okay, so that's not been defined. We also would like to be able to do, as I said, 2 times a, where the a now is the vector is on the right hand side and the number is on the left hand side. These are slightly different, so that's what's going to make operator overloading for these today a little bit different from what we did last time. Okay, but like we did last time, let's kind of like do a little prelude, and let's do a dot multiplied by, say, well, I'll create a method called multiply by scalar, and we'll multiply by number 2. Okay, multiply by scalar doesn't exist, so let's go and implement it. Here we are in our vector class. We can put mul by scalar down here, and the scalar alpha is probably a suggestive number, and this is going to return a vector. Oops. Okay, so implementation of this should be pretty simple. If you would like to pause the video and try your own solution now, go ahead. But I will carry on. So here, all we really need to say is, okay, this number, by the way, on the right-hand side, I think it doesn't matter whether the scalar is on the left-hand side or the right-hand side. That's sort of an axiom of scalar multiplication, is that 2 times a vector is the same as a vector times 2. In other words, when a scalar multiplies a vector, the result is what we call commutative. That means we can kind of commute the two things, we can switch them, and it's still okay. Okay, so I am going to say this is this times alpha, and this dot y. Whoops, make sure you get your operator right. We'll do that again. This dot x multiplied by alpha, and this dot y multiplied by alpha. Let's go back, mul by scalar. So there's the mul by scalar. Just get a little bit of white space or format document. So 2a is 2e1 plus 4e2. Great, that's what we want. Let's go and visualize that too. So we'll go board, create arrow, and we want to visualize the vector, which is 2a. And we'll leave it positioned. As you can see, we'll start at the origin, and it's going to be called 2a, whatever that looks. Okay, and that's kind of what we want. A is the vector, which is 1e1, 2e2, and 2a is 2e1 and 4e2. Great, so we're sort of off to a good start, but what we want to do now is we want to replace this multiply by scalar with something that looks a little bit more like math. So we want to evolve from that to something that's more like a times 2. Okay. So notice that in this case, before we actually go and implement this, that a is on the left-hand side and the 2 is on the right-hand side. Okay, so the number that we're trying to multiply is on the right-hand side. So let's go to our vector class, and we want to overload the multiplication operator. So the method that we need to define is called mul. Okay, and the right-hand side, as I said, this time is a number, and what it's going to return is a vector. Okay, and then just as before, where the add method could reuse the this.add, we can reuse this dot mul by scalar, and we put the right-hand side in. Okay, and just do a little formatting. Let's go to our main line, and as you can see, it worked. We've got a there, we've got 2a there. Okay, let's do the other way. Let's do 2 times a. Okay, and then once again you can see that it didn't work out. Nothing's been evaluated. Okay, that is because what we need to do is implement a slightly different operator overload, where now the a happens to be on the right hand side. Okay, so that method that we implement is called right multiplication. So we are going to have an rmul, okay, where the number that we want to multiply right now is on the left hand side, okay, and we are on the right hand side. Now this is not important for scalar multiplication because we know it commutes, but going forward with geometric algebra it's going to become very important. So in addition to making this work, you should start to question every time that you do multiplication, am I allowed to flip the two operands in my expression? An example where you can is like addition. An example where if you flipped it, it would give the wrong sign would be subtraction. Okay, you change the ordering. A minus b is the negative of b minus a. There are going to be other operators though when we come across them, where if you reverse if you interchange the two operands, the two things that are being operated on, you'll get some kind of completely different answer. Okay, so just look for that as we go forward in future. So the good news is that we actually now have scalar multiplication by a vector. We have implemented also MathJax, so we've got sort of rather more elegant output here. And we've also learned a little bit about using the JavaScript documentation to improve our code. I'll leave it as an exercise for you to document the mul by scalar method and the toString method to just make those a little bit more friendly for anybody who wants to use them. I hope you enjoyed that very short video, relatively short video. This video has moved us along a fair way with our vector, but there is still more to do with vectors. We have yet to define anything related to the magnitude of the vector. We don't know how to compute angles between vectors. And then there are a few other little odds and ends that we want to just tidy up before we're done with the vector. But we will be able to move on very shortly to turning this into what I would call a geometric number. I hope you enjoyed this. If you liked it, please hit the like button. And if you want to see more videos in the geometric algebra in STEMCstudio series, then please hit the subscribe button below. Thanks very much. Until next time, happy coding.